Hello, class. This will be our second lecture from Unit 2. And so um, the the 5.6, I don't know if you've looked ahead yet in the in my math lab, but it is split up into two homework sections. There's a 5.6a for exponent rules and a 5.6b for scientific notation. So those topics are related, but they're definitely like a different flavor of problem, I guess I would describe it. And so rather than have one long video together, I'm going to split it up into two short videos. All right, so as always, I am doing my lecture notes from Blackboard. So if you are, the student study resources for Unit 2, lecture note outlines, this is 5.6. So if you're following along at home and with the printouts, here it is. And I will say that now that I've taught this in my in-person class, I realize I think this is an old version of the exponent notes. So I'm going to skip around a bit when I'm covering that. Um, it has most information, but it needs to be ordered a little bit better. And there's a couple things missing. Um, for the most part, we're using that. And then once we get into the next video with scientific notation, it'll be a continuation of the same handout. All right, so let's get into the notes. Big picture, the other thing, I knew there was something I was forgetting, is the reason that we are covering these two sections is we have a little bit of time in our schedule. And so rather than, I can't really teach some of the other survey topics I want. So these two topics, along with the interval notation that we did for the first assignment, are definitely for those of you going on next semester to college algebra and chemistry. Specifically, the exponent stuff that we're going to talk about in this video. This is something you definitely use in college algebra. The scientific notation, that is specifically for chemistry students. It works in any science class, but that's more for chemistry. Right, so these assignments are an extension of what we've done before. It's looking ahead since about half of you are going to be going on to college algebra next semester. All right, so let's talk about exponent rules. So when we're talking about exponent rules, what makes this different from what we covered in the first unit? For survey, when we're dealing with variables, for the most part, we're just adding and subtracting them. And we use that phrase combine like terms quite a bit. And so, from the first test, you can't add variables unless they have, or terms unless they have the same variable with the same exponent. And then when you do, you're not changing the exponent, you're just adding, subtracting coefficients. And when we were distributing, we only distributed a constant, we didn't distribute variables. Well, in college algebra, you're going to be distributing variables, you're going to be multiplying, you're going to be dividing these variables all over the place. And so that's what we're talking about today is the rules for what happens when you multiply and divide variables. And as we talked about with fractions and with integers, multiplying and dividing almost always has different rules than adding and subtracting. And so we're not talking about combining like terms anymore. We're talking about what happens if you specifically if you multiply or divide variables. So big picture, that's what we're doing. All right. So real quick, doesn't hurt to review. So because it's still something got missed on the first test. Yeah, what is the difference between having parentheses on the second one and not having parentheses on that top one of that minus 6x squared? So if that negative's inside the parentheses, there are two of them because it gets written out twice. So that would be a positive 64. On the top one, when there is no negative, or sorry, when there is no parentheses, that there's only one negative when you write it out, and that becomes positive. Oh, sorry, negative. Sorry, it's been a long day. Okay. So I've been doing this for years and I still make mistakes. But there is one negative because that parentheses, there is no parentheses, so it doesn't get written multiple times. And you're going to see this again as we're going through these rules today. Parentheses matter. If they're there, it means one thing. If they're not there, it can mean another. Okay. Something else that got missed on that first test is something like number 3. So we have 10 times 2 to the third power. What do we do first? Do we do the multiply or do we do the exponent? Well, what a lot of people missed in that first test, they were multiplying before doing exponents. That is definitely not in your order of operations. So the first thing you're supposed to do here is 2 cubed, which if you want to write it out, it'd be 2 times 2 times 2, which is 8. And then 10 times 8 is 80. If you looked at that and said, well, I'm going to do 10 times 2 first, which is 20, and then cube 20, you're getting a completely different answer that is completely off track because exponents are before multiplication. All right, I think we'll skip the one with fractions. We've talked about that in the last unit. Okay, so as we are going through this section, we're going to develop shortcuts on how to deal with the exponents on these variables. So one of the things that you can do, if you forget the shortcut, you can always go back to like writing out what the exponent means. And so what do I mean by that? Well, if we're going to simplify x squared times x to the 7th, well, what does x squared mean? It means x times x, and then x to the 7th means not 7x's. I'll multiply 4, 6, 7. All right, so we're multiplying a bunch of x's. So this is repeated multiplication. And so notice it says use exponential notation. So when you're using exponential notation, that means we need a base and we need an exponent. So the base is clearly x because that's what's getting multiplied. So now the question is, what is the exponent? How many x's do we have here? We have 2 here, 7 here, so that's a total of 9. We know x multiplied by itself 9 times. All right. Now, you can always go back to the basics and write it out like this, but that can get tedious. Like if we had x to the 6 times x to the 8, you don't want to write that out 6 times and 8 times. And what if that was like x to the 20th times x to the 30th? You're not going to want to write those out. So these rules that we're going to talk about are basically shortcuts to describe this. So where did that 9 come from? Well, that 9 came from the 2 and the 7. So 2 plus 7 gives us 9. So this is what we refer to as the product rule. So if you're multiplying the same base, you're going to add the exponents. You don't change the base, just add the exponents. I'm going to start a second page with all our rules. Yeah, I would definitely recommend that you somewhere in your notes, so like you have a summary of these rules. Okay, so there is our product rule. So how do we apply that? Okay, so here number 9, we have t to the 5th times t to the 9th times t squared. Zoom in a little bit here. All right, so how do we simplify this? Well, we have a bunch of t's multiplied. So we're going to add the exponents. So 5 plus 9 plus 2. So that is t to the 14 to the 16th power. Now, a lot of times in a class when we're doing this, I'll have students say the answer is 16, which I know what they mean. They mean the exponent, but you need to be careful on how you talk about this because if you're not putting the base and the exponent, you don't have exponential notation. And if you practice kind of being lax in how you talk about it, then a lot of times, like that base would go away and people would just answer 16. Okay, so try to be a little bit more precise when you're talking about it, because how we talk impacts how we think and vice versa. There. So this one looks messy. Number 10, a to the 6th times a to the 4th times a to the 8th times a to the 7th times a to the 8th. Well, it turns out it doesn't matter how many terms we're multiplying, those are all a. So we're just going to add all the exponents. So 6 plus 4 plus 8, 7 plus 8. All right. And it's not cheating to grab the calculator. So add all those up and you get an exponent of 33. All right, so this is where we're missing some examples. So I'm going to go off script. What if we're simplifying x to the second times x to the fourth? What is that? Well, often I hear x to the sixth. Well, if that's what you're looking at, that's what you're thinking, you've just made the common mistake here. Okay, so why is it not x to the sixth? Well, some of you probably got this. There is an x there. What's the exponent on that x? Well, if it's not 1, it's understood to be 1. Right? So you may want to, when you're doing all these rules with the exponents, I would highly recommend that you write that 1 in there so you don't forget it. So we're really doing x to the 2 plus 1 plus 4 plus x to the 7. Okay. So watch out for that. Those variables without exponents do have an exponent with them. Okay. So what about number 11? Now we have 8 to the ninth times 8 to the third. Typically hear two answers here. So is it 64 to the 12th, or is it 8 to the 12th? When in doubt, you can always go back to writing out what that actually means. So that's 8 eighths, sorry, 9 eighths. And I'm not going to write all those out. Okay. But what is the base here? The base is 8. 8 is what is getting repeatedly multiplied. Okay, so when you're multiplying your variables and adding these exponents, you do not change you don't change the base. All you do is add the exponents. So what's getting multiplied here is 8. So don't multiply 8 times 8 to get 64, because 64 is not the base. It's 8 that's the base. Okay? And so sometimes with these exponent rules, actually having variables in here is a little bit more straightforward than having numbers. Because again, like I said, I think the reason people do this is they see 8 times 8 and want to multiply it out. Now, this is the exponential notation. So sometimes in math lab, well, not all sometimes, but make sure you're always reading the instructions. And so when it says it wants an exponential notation, you would answer 8 to the 12th. But if they say evaluate it, what does that mean? Spell today. Well, evaluate means plug it into your calculator. So if you plug this into your calculator, right? So remember for these calculators, that up arrow is your exponent key. So you do 8 to the 12th. All right, so what is that number? What does that mean? That's 6.87194, a bunch of numbers, times 10 to the 10th. Well, often what I hear is students don't know what that means, so they ignore it, so they answer just 6.87. This is definitely not 6.87. So what does 10 to the 10th mean? Well, 10 to the 10th means 10 times itself 10 times. And if you're familiar with this, what that means is that's 1 followed by 10 zeros. 10. So that would be, what is that? Thousands, millions, billions. So 10 to the 10th is 10 billion. So this number up here, 6.87 times 10 to the 10th, is basically 6.87 times 10 billion. So that's like 68, almost 69 billion. There's a huge difference between 6.8 and 68 billion. All right, so what we're talking about here with this times 10 to the 10th, that's scientific notation. So that's our next video. The scientific notation, one of its purposes is to write really big numbers or really small decimal numbers in a shorthand. Because your calculator, it doesn't have this many digits, it can't give you an answer. Right? Even without the calculator, a lot of times it's helpful just to have a notation for these really large or really small numbers. So we're going to come back to this next video. The other thing is MATLAB is not always consistent. So if it's a small number, if it was like 8 cubed, then they may just say evaluate it. An 8 cubed is a smaller number. That's 512. So they may want that answer and not say exponential notation. They may just say simplify. If you're not for sure if they want the exponential notation or the plug it into the calculator, in the homework, you can always go to the example, scroll down to their answer, and then put your answer in whatever form their answer is. So if their answer is an exponential form, it's exponential form. If they're just it looks like it's a number put in the calculator, then do that for yours. So they are a little bit inconsistent on that sometimes, particularly for smaller numbers. When you get into scientific notation, that's a whole other beast. Okay. All right, so how about number 12? Getting kind of messy here, so let me write this on the paper. We have 4p squared times negative 8p to the 8th. So how do we multiply those? Or can we even multiply those because the exponents are different on the p's? Well, if you're debating that, in a way that's good because we just got through a section where we were combining like terms where we're adding, subtracting. And so if this was an add or subtract problem, we couldn't do anything because the exponents are different. But remember, multiply and divide has different rules. So we can multiply variables that have different exponents. And so how do you multiply this? Well, this is all multiplied, so the order doesn't matter. So what you're going to do is you're going to multiply numbers with numbers, p's with p's, x's with x's, y's with y's. And so we arrange this, put the numbers with the numbers and the p's with p's. So now how do you multiply this? Well, your numbers are just like you've been doing since elementary. That's negative 32. And then how do you deal with p squared times p to the 8th? Multiplying the base. So we add the exponents. So 2 plus 8 gives us p to the 10. Great. So how about, let's jump down to another, a little bit messier one. So number 14. So this is negative 5, negative 4. Sorry, I was looking at that. So negative 4, x to the 4th, y times negative 6, x to the 5th, y cubed. And I don't know about you, but I'd felt more careful that being in parentheses instead of the multiplication dot. But how do we multiply this? Well, we have numbers, we have x's, and we have y's. So I'm going to put the numbers with the numbers, the x's with the x's, and the y's with the y's. So go ahead and give that answer, and then we'll discuss it. All right, so number-wise, we got 24. For the x's, we're just doing 4 plus 5, so we just x to the 9th. So what are we going to get for y? If you're saying y to the 3rd, you're missing something, which is a common miss. And so if you got y to the 4th, you remember that there is that 1 there. So we're doing 1 plus 3. That's where we're getting y to the 4th. All right. Now, you notice my notes, I started to hesitate when I circled it because I remembered I had another question. This is the right answer, but one thing you have to be careful of, can you combine the exponents on the x to the ninth and y to the fourth? Can you make that like xy to the 13th? And the answer is definitely not, because we only deal x's with x's, y's with y's, and so on. Because if you think about writing this out, you're going to get 9x's, you're going to get 4y's. There's no way you're getting 13x's or 13y's because the letters are different. Okay, so this isn't exactly like combining like terms because that phrase is for subtracting, but with variables, you're still multiplying numbers with numbers, x's with x's, y's with y's, and so on. All right, so that is the product rule. So if you're multiplying the base, you add the exponents. Right. How about number 15? What's the mistake there? Why is x to the fifth times x cubed? Why is it not equal to x to the eighth? That's definitely a mistake. Hopefully by now you're catching on to that. So that's there's an x to the first there. That should have been x to the ninth because you have the one. All right. What mistake was made on 16? Well, where did the 24 come from? 4 times 6. And a lot of times students will say, well, that's a silly mistake. Not really, because once we get into these exponent rules, and particularly if we're in college algebra, we're doing a lot more of them. I think students get so used to doing the shortcuts with the exponents, they do that with numbers as well. But that's just 4 to the 6th power. So that's 4 times 4 times 4 times 4, 6 times. All right, so just be careful. These exponent rules are a base and an exponent. Try not to, confuse them with regular numbers as well. All right, and then on 17, why are those not equal? Well, it comes back to what is getting cubed? Remember we talked about parentheses being important with negatives? It works the same here, right? So if there is parentheses, that tells you what is getting the exponent. So this is 2x times 2x times 2x. Then how do you multiply that? Well, 2 times 2 times 2, that's 4 times 2, which is 8. And then x to the first, x to the first, x to the first. That's where we get our x cubed. Whereas this, the only thing that's getting the cubed is the x, because there's no parentheses. I can't emphasize enough how much parentheses matter when we're dealing with exponents, because that tells us what the base is. All right. So on the handout it's division next. I'm going to come back to that. Like I said, these are a little bit out of order. They need to be revamped, but we'll work with it. All right, we'll come back to the division. Okay, so go to 24. So now we have y squared to the third power. Okay, so now we have a power raised to a power. Okay, and so let's assume you don't know the shortcut. And so when you do this, if you write it out, what does anything cubed mean? Well, it means that term times itself 3 times. So it's y squared, y squared, y squared. And so now how do we deal with that? Well, now we have the base multiplied. So we're just doing y to the 2 plus 2 plus 2, or y to the 6th. All right, so we don't want to have to write this out every single time. It's like if you look on the next one, if that was x to the 4th to the 20th power instead of the second power, you don't want to write that out 20 times. I'm assuming. I know I don't. So where did that 6 exponent come from? Well, it comes from 2 times 3 because we're basically adding 2 to itself 3 times. When you have a power raised to a power, you multiply. And that's what we refer to as the power rule. The power rule says you have x to the a to the b power, you're going to multiply the exponents. And we're going to do a few more of these exponent rules, but those are the two that get mixed up the most. So whatever you need to do to try to remember them. Again, if you write them out, it helps. And most of the time, we're multiplying the bases. We're not raising powers to powers. So that's going to be the more common rule. All right. So what do we do with that? Well, so at 27, so we have x to the ninth to the third power. So we have power raised to a power. So you multiply the exponents. So 9 times 3 gives us x to the 27th power. So what about 28? X to the fourth to the eighth power. Well, we have power raised to power, so we do 4 times 8, x to the 32. Now for this class, we don't use this rule very often. Again, we're just kind of getting your feet wet. So for those of you going on to college algebra, we'll have some of the basics. So for us, this is good enough for the power rule. Okay, so now let's go back and do our division. So number 18, we have a to the eighth divided by a cubed. So again, let's assume we don't know the shortcut. So let's write this out. So a to the eighth is 8a's, a to the third is 3a's. Now treat this just like a fraction. What can you simplify? Or what can you cancel out? Well, 3a. It doesn't really matter which 3a's as long as it's top to bottom. So I can do that a and that a, do that a and that a, like this a and this a. As long as we're only dividing out 3. So now what do we have left? Don't tell me nothing on the bottom. Because it's 1 times 1 times 1. So there is a 1 on the bottom. And on the top, we have a bunch of a's multiplied. Well, how many a's? 1, 2, 3, 4, 5. So we have a to the fifth on top. And so anything divided by 1 is that whole number. All right. So we did a to the eighth divided by a cubed, got a to the fifth. And again, we don't want to write this out every time. So what is the shortcut here? Where did that 5 come from? Well, the 5 came from 8 minus 3. So that is our quotient rule. The quotient rule says if you have a to the x to the a divided by x to the b, it is the a minus b for the exponent. So it's the top exponent minus the bottom exponent. Now, I will show you a different way to think of that when we get into some of the messier problems. But that's for the product rule, if we're multiplying variables, we add the exponents. If we're dividing, we subtract the exponents. Where's my examples go? All right. So how about a to the fourth divided by a? Well, hopefully you said a to the third. And where did we get that 3 from? Well, that a on the bottom is a to the first. So the exponent is for minus 1. We get a cubed. So what would the answer be on 20? X to the ninth divided by x to the eighth. 9 minus 8 for the exponent, so x to the first, or just x. Pretty straightforward, hopefully. And so what gets messy is once we start mixing all these in. Now, again, we're kind of just doing the basics with this. We're not going to get near as messy as a college algebra class would or an intermediate algebra class, because we want to try to find a balance between getting some of you ready for college algebra and then not overloading the algebra for the students who don't need it. So we're trying to find a medium ground with all this. Okay, so that is division. Okay, so once again, I need to go kind of off track on my rules. And so how about, this is not on the paper. The next several are not going to be on the paper. What if I give you x to the fourth divided by x to the fourth? Well, let's do the quotient rule on this. So the quotient rule says when you're dividing your variables, you do the top exponent minus the bottom exponent. So we're gonna do 4 minus 4, which 4 minus 4 is 0. So now we have an exponent of 0. So this is normally if I was in a class and I would say how many people have seen a 0 exponent. Usually I'd get like 1 to 2, maybe 3 hands pop up. This is something we don't deal with as often. Okay. So what does it mean? I'll put a pin in it. We're going to come back to that. So let's do this a different way. The one again with these variables, we can always write them out. So we have 4x's on top, 4x's on bottom. So what do we get when we start dividing? Well, x divided by x is 1, x divided by x is 1, and we can do that 4 times. So what do we have left? And please don't tell me 0, because we still have something left. Because we have 1 times 1 on top, 1 times 1 on bottom, so we get 1. All right, so what we've done is we've done this problem 2 different ways, not legitimate ways. We get different answers. That means the answers are equivalent or equal. All right, so when you have a 0 exponent, what that means is that you're dividing something by itself. And other than 0, which we can't do 0 divided by 0 because we can't divide by 0, anything else to the 0 exponent is 1, just by definition. And so that is our 0 power. X to the 0 is 1. And one thing this kind of points out is that normally when we talk about exponents, we talk about it being repeated multiplication. Like x to the 4th is x times itself 4 times. But what does x times itself 0 times mean? I don't know about you, but that doesn't make sense. And so that language that we typically use for exponents, that only works for positive whole number exponents. Doesn't work for 0 exponent, doesn't work for negative exponents, doesn't work for a fraction or decimal exponents. So that idea of repeated multiplication is kind of a narrow view of exponents. If you want to know more, probably need to be a math major. Okay. All right. So let's play around with this. So what would be y to the 2? That's y to 0. So anything 0 power is 1. What about 4 to the 0? Hopefully you're starting to get the idea. Let me see. Let me double. I'm pretty sure calculator can handle this. Yes, calculator can handle a 0 exponent. So what if I give you negative 4 to the 0? What is that? When in doubt, why is that negative 1 and not positive 1? Well, here's a hint. Parentheses versus non-parentheses. So what is negative 4 in parentheses to the 0? That is 1. So why is this 1? Why is this negative 1? Well, as we've mentioned before, that negative is inside the parentheses, so that's part of what's getting the exponent. So this essentially means negative 4 divided by negative 4, which is 1. This negative is not inside the parentheses. So essentially what's happening, that negative is getting carried over, and we're just doing the opposite of 4 to the 0. What's 4 to the 0? It is 1, and we're taking the opposite of 1, which is negative 1. So again, parentheses matter. Just give you like a messy version of this. How about x to the 5th times y to the 8th, z all to the 0 power. What are we saying? 1? Because I don't care what this is inside the parentheses as long as it's not 0. This is something to the 0 power, which means we're doing this divided by itself, which is 1. Okay. What about 2x to the 0? And 2x with parentheses to the 0. Hopefully you're saying this is 1 because we have something to the 0 power. But what is this? Well, we have, since 2 is not in parentheses, it's only x to the 0. So we got to do the exponents before multiplication. So we just bring along the 2. The next to the 0 is 1. And then 2 times 1 is 2. So this is really not something that's unique to the 0 exponent. This is a parentheses and exponents issue. Because those are definitely different because of where the parentheses is or isn't. Right, but just try to remember in general, if you have a term to the 0 power, by definition it's 1 because we're dividing that term by itself. Okay. Now we're getting to the fun part of the exponent rules. Let's find out where I'm at in the notes. And I definitely need to redo this. Okay, so let's do x to the 3rd divided by x to the 5th. Again, let's do it 2 ways. So what is the quotient rule for this? Well, the quotient rule says you do the top exponent minus the bottom exponent. So it'll be x to the 3 minus 5 or x to the negative 2. And so normally, if you haven't seen a 0 exponent, it probably means you haven't seen a negative exponent either. So what does this mean? Well, let's back up and write this out and see what happens. So x cubed divided by x to the 5th is 3x's on top, 5x's on bottom, and then we can start canceling stuff. X is 1, x divided by x is 1. Okay, so what do we have left? Well, on the top, we have 1 times 1 times 1, which is 1. On the bottom, we have x times x, so it's x squared. So we've done this problem in 2 legitimate fashions, and so that means the answers are the same. So x to the negative 2 is 1 over x squared. What does that negative exponent indicate? Well, if you think of this as being over 1, what we do with a negative exponent means we're going to have to flip the variable. So that variable, if you think it was top of the fraction, has to go down to the bottom of the fraction. And when you flip it, the exponent, not the variable, but the exponent changes signs. All right. So we write up the rule, and we're going to do more examples on this because this is the messiest version of the exponent rules. So this is our negative exponent. And there's 2 versions of this. So one is if we have x to the negative n. So basically it's in the top, think of that as over 1, it's in the top of the fraction. That becomes 1 over x to the positive. So that's kind of that's what we just did here with x to the negative 2, 1 over x squared. Now, if that negative exponent starts in the bottom of the fraction, so we have x to the negative n, now we need to flip it up. Basically, you flip that, and again, the exponent becomes positive, becomes x to the n over 1, which is just x to the n. All right, and so kind of 2 general things you need to know about this negative exponents for this class is you can't stop your answer when there's negative exponents. That would be like giving me a fraction and not simplifying it. So this is not necessarily incorrect, it's just not in the preferred form. Okay. So if you have an answer that has a negative exponent, you do need to flip that item that has a negative exponent. The other reason we're talking about this is with the scientific notation, we're going to see negative exponents, and they mean that we have decimal numbers instead of big numbers, and we'll explain why once we get into scientific notation. All right, so let's do some examples. Simplify y to the negative 8. So anytime we have a negative exponent, there's going to be a flip. So if you think of that as being at the top of the fraction, we're going to flip it down. You have 1 over y to the positive 8. What if we have 1 over x to the negative 5? Well, now the term with the negative exponent is in the bottom, so it needs to get flipped up. So now that becomes x to the positive 5 in the top over 1, but then over 1 just means a whole number. Good. And this is where I really wish I could like pause and see where the questions are, but we're just gonna, I guess you'll have to pause and rewind if there's questions. All right, let's keep doing examples. What if we have 2x to the negative 3? So here's a question. We have a negative exponent, so something's gonna get flipped. What's gonna get flipped? The most common answer I get at this point is the 2 and the x go in the denominator. However, that's incorrect. And the reason being is our old friend parentheses. So these are very different problems. So in the top one, what's the exponent on 2? Well, it's not inside the parentheses, so it's definitely not negative 3. So that's really 2 to the first power. So the only thing that gets flipped is the term or terms that have a negative exponent. So in this case, the 2 is going to stay basically up in the top of the fraction. The x cubed is going to flip down in the denominator, and so we get 2 over x cubed. Now for the next one, because of the parentheses, both of them are going to get flipped down to the bottom. We want over 2x in parentheses cubed. Now this one we can do a little bit more with because if we have 2x cubed, it means 2x times 2x times 2x. So really what we're doing, since those are both in there multiplied, we're cubing each of them. So then 2 times 2 times 2 is 8. And then x times x times x is x cubed. So math, I would probably prefer that. Again, because they're not always consistent on the form when it comes to numbers. Since we can do 2 cubed to get 8, they're probably going to prefer that. If this was a test question, I would be more than happy with 1 over 2x in parentheses cubed. If you didn't put the parentheses, you'd be wrong because then you would be cubing the 2. Which in that case, it should have stayed up in the top to begin with. All right. How about x to the negative 4 over y to the negative 2? What's going to happen here is they both have negative exponents, so they're both going to get flipped. In this case, the x negative 4 gets flipped to the denominator, y to the negative 2 gets flipped to the top. We get y squared over x to the 4th. Those are different variables, so don't do anything with the exponents after we flip them. All right. Now, I will say that when you're going through the homework, you're going to see a lot of questions in the middle of it that have got have a note that says removed by instructor. The reason for that is when I went back and looked at the homework, for some reason there was a lot more homework problems in there than I wanted. There was some that were definitely redundant. and also some of them that were messier than we need to be. Some that were more definitely college algebra level. So I took a lot of those out, again, just to kind of simplify the homework. Because again, not all of you are going to college algebra, so I'm not going to throw a bunch of college algebra level stuff at you. We're just, again, we're kind of just wading in the shallow waters here. All right, so those are all our rules. So product rule says if you're multiplying the variables, you add the exponents. If you have a power raised to a power, you multiply the exponents. If you're dividing, you subtract the exponents, always top minus the bottom. And this is where we get our zero power and our negative exponents, just from the subtraction. If you have something to the zero power, that's 1. If you have a negative exponent, you're going to have to flip your variable and make the exponent positive. All right, so let's do a couple of problems that this might all be pretty fine. We go back to the handouts, number 30 that I'm going to do first. We'll do the 20, we'll do 30 and then we'll back up and do 29 because division's always a little messier. All right, so for 30, simplifying, you have negative 3x to the 4th, y to the negative 4th, 5x cubed times y to the negative 2. Okay. So these are starting to get a little messy. And one thing about the messier problems that you're going to get towards the end of the homework, often there's more than one way to start the problem. But what really matters is where you end up. So I'm going to do this a couple different ways, pick up those negative exponents and show you a couple different ways that, and let you figure out which way works better for you. All right, but how do we start this problem? Well, this is all multiplied. So I highly recommend that you put the numbers with the numbers, and the x's with the x's, and the y's with the y's. So negative 3 times 5, we have x to the 4th, times x to the 3rd, and then y to the negative 4th, y to the negative 2. All right, so the numbers in the x's relatively straightforward on this one. That's negative 15. And for the x's, we have 4 plus 3. That would be x to the 7th. Now for the y's, we have a couple of different ways that we can approach this. So one way to do it is with the product rule. Okay. So the product rule says we have two variables that are multiplied. So we're going to add the exponents. So we would have negative 4 plus a negative 2. Because the product rule doesn't say anything about positive or negative, it just said add the exponents. So the negative 4 plus negative 2 is negative 6. Okay. And so now, are we done? Almost, but we can't stop when there's negative exponents in the answer. So now, so we have a negative exponent, so something's going to get flipped. So what gets flipped? Only the term that has a negative exponent. Negative 15 has like that's a positive 1 exponent, it's x to the 7th. So only the y is going to get flipped. That means we have negative 15 x to the 7th in the numerator, and now y to the positive 6 in the denominator. And then don't do anything else because those x's and y's are different variables, so you cannot combine their exponents. All right. So let's look at this y to the negative 4, y to the negative 2, slightly different way. So the other thing that you could do is rather than do the product rule first, you could do the negative exponent rule first. And so we have two terms that have negative exponents. So both of those terms are going to get flipped to the bottom. So that becomes 1 over y to the positive 4 times y to the positive 2. Now what do? We use the product rule because now we're multiplying variables again. So 1 over, well, 4 plus 2 gives me y to the 6th. And guess what? there is our times y to the sixth. Essentially what we're doing is negative 15 times x to the seventh times 1 over y to the sixth. So then you just put these two over 1, and then that's your top, that's your bottom. We get the same answer. So whether or not you flip them first or you do the power rule, I kind of like doing the power rule first because sometimes once you add them, you don't have negative exponents anymore. But just as you're going through the homework, play around with these negative exponents a little bit. Get used to them, kind of see what works better for you. All right, so that's 30. So that's what we're multiplying. All right, so let's do one last example, and we're good with this section of notes. The 29, we have 63 x to the fourth, y to the negative 3 over 9 x to the seventh, y to the negative 7. Right, now my hint on this is just like with the multiplication, we split it up into numbers with numbers, x's with x's, and so on. Treat this like three fractions. 63 over 9 times x to the fourth over x to the seventh times y to negative 3 over y to the negative 7. So what do we do with that? Okay. This is just a fraction. So sometimes once people do the exponent rules a lot, and when you see a division, you want to subtract. So sometimes I'll see students do 63 minus 9. But remember, those are numbers. Those are not exponents. So those are bases. So 63 divided by 9 is just our normal 7. Then we have x to the fourth over x to the seventh. And so the quotient rule says we subtract the top minus the bottom, which would give us x to the negative 3. I'm going to come back to that. Now over here, again, we have a couple ways we can do this. If you want to do the subtract rule, or sorry, the quotient rule, here you have to be careful because we have negative 3 minus the bottom, which is negative exponent, which is negative 7. So there is a double negative going on there. So now we're doing negative 3 plus 7 for the exponent, so it's y to the fourth. The other way that you could do that is you have two terms that have negative exponents, so you could actually flip them both. Y negative 3 goes down, y negative 7 goes up. That would give us y to the seventh over y to the fourth. Then you could apply the quotient rule, not have any negatives to deal with. It'd be 7 minus 4 or y cubed. Where did I go wrong? Oh, it's supposed to be negative 3, so that's supposed to be positive 3. Sorry about that. I think my brain knew 4 was the answer, so it was working ahead of me. All right, so, but if you notice, we got y to the fourth either way. So whether you want to do the quotient rule, and this gets a little messy because of the double negatives, or whether you want to flip it first, whichever works better for you. And now if you notice, let's go, so now that takes care of the y's. We're not quite done because of x to the negative 3. And here's where, again, we have to be careful. What do we flip? Only the term that has a negative exponent. So that, because that 7 is a positive 1. So what's our final answer? 7 y to the fourth on top, x to the positive 3 on bottom. All right. So for those of you going to college algebra, you get to play a lot more with that. Notice we didn't use the power rule, power ratio power very much. That's something that's more of a college algebra thing. The only other thing I'd point out is sometimes I use common sense with the quotient rule. So particularly on this x to the fourth over x to the seventh. I've been doing this a long time, and so what I prefer, I try to avoid negative exponents if I can. So what I do is I do the subtract rule, but I always do the big minus the small. So when I look at this, I would do 7 minus 4 and get x cubed. But then I ask myself, where are most of the x's? Well, there's more x's in the bottom, so that x cubed that I have is going to be in the bottom. So I kind of bypass the negative exponent rule just by using my common sense to tell me if the x's are going to be in top or bottom. If that helps, great. If not, ignore it and just kind of do what we did here. All right. So that concludes the notes for 5.6a, our exponent rules. Have a good day.